We are going to talk about absolute value inequalities. But before we do that, I want to make sure we're all on the same page about what an absolute value is. So the absolute value of a number is denoted by putting that number between two vertical bars. So this is the absolute value of 5. What the absolute value does, the absolute value of a positive number is just that number. The absolute value of a negative number, well, it's that number without the negative sign. So the absolute value just takes a number and makes it positive if it wasn't positive already. You might be familiar with the absolute value in terms of the number line. That the absolute value of a number is its distance from 0 on the number line. So the absolute value of -7 is +7. On the number line, here's 0, -1, -2, -3, -4, -5, -6, -7. And there are 1, 2, 3, 4, 5, 6, 7 units between them. More useful for our purposes and maybe more helpful overall is that the absolute value of one number minus another number is the distance between those numbers on the number line. So let's look at, here can be 0, -1, -2, -3, -4, -5. There are clearly 3 units separating -2 and -5. And if you subtract them, subtracting a negative adds it, remember. So that's negative 5 plus 2. We do indeed get 3 units. And you're used to order mattering when you do subtraction. But in an absolute value sign, if we'd subtracted them in a different order, we'd still have gotten 3 units. This gives the key to where absolute value inequalities show up all the time in the real world. And that is error. So, a poll finds that 76% of Americans support a new law, but there's a margin of error. The poll isn't exact, and we estimate using statistical resources that the margin of error is about 3.7%. So the real number could be bigger than this, it could be smaller than this, but it shouldn't be more than 3.7% away in either direction. Let's try to rephrase this. Let's let x be the real percentage. And let's rephrase this in terms of distance. The distance between x and 76 is less than 3.7. X could be greater than this, x could be less than this, but x should not be more than 3.7 away from this. The distance between x and 76 we have now seen can be written as the absolute value of their difference is less than So here we have an inequality involving an absolute value. And we see inequalities like this a lot when we're measuring error. So in the next video, we'll discuss how to solve inequalities like this. And this is our motivation for looking at these questions?